the test. Okay. So with that being said, and the recording fixing to start, I'm going to go to my handy dandy homework. And even though I did the office hours, I'm going to go over those 4 questions again. And I'm going to introduce the table for those that might want to see the table, because the table, you know, this thing right here I just sent y'all, y'all might want to know how to use it in case you're asked to use it. Okay, so with that being said, this is 7.1 13 slash 13 slash 5. 7.1 13 slash 5. Now I think we went over one like this, I'm not sure, but it is a time question. The first thing I'm going to do is I'm going to draw the picture. And it's time, so it's going to look like a rectangle. And we've got a rectangle from 0 to 30. So 5, 10, 15, 20, 25. And this one does give us the height equal to 1/30. A says find the probability that somebody will be between 10 and 20 minutes late. Okay, I've got it written down here. And then B, there is a 0.2000 probability that somebody will be late. Turn that into minutes. Okay, now like I said, we went over one of these in class, and I'm going over it again. It's time, and that is the question.
I can't print out what you said for us to print out those things because my printer is not connecting to my laptop.
Okay, well you can. They're in your section, and plus I'm only showing it to y'all in case you need it, like on a test. You can use your calculator. It's just another way to. You can print it out at work tomorrow if you want to. Can you?
Yeah, that'd be fine.
All right. So it's just I need to show it to you in case if you ever take a standardized test and you see the table. I don't want you to go, oh my God, Hubert never showed me that. So that's why I wanted to do it. Okay. So now I'm going to do A. I'm going to take my handy dandy highlighter and I'm going to use orange. And we're going to do 10 to 20 minutes late. So 10 is right here. So I'm going to do that. And then 20 is right here. And I'm going to take my orange highlighter and I'm going to highlight that area. So the orange area is what the question A is asking. They want to know how big that area is. So we take our handy dandy pre-algebra formula. Area of a rectangle is equal to base times height. And that's going to be base is 10 and height is 1/30. And that's equal to 10/30. And I don't care how you calculate it. If you want to cancel out the zeros and make it 1/3 and then make that equal to 0.33, or if you want to take 10 divided by 30, everybody's going to get the same thing as 0.3333. Now, I want to talk about what this means, 0.3333, because the question is asking what kind of context are we dealing with? Okay, first of all, there's one thing you can say. The area between 10 and 20 minutes is 0.3333. Okay, that's one way, that's one context. The second context is to say there is a 11.01% that a person will be 10 to 20 minutes what? Late. And then the last way is to say 3, the probability of being between 10 and 20 minutes late is equal to 0.3333. Those are the 3 ways that you can define this 0.3333 in the orange area. Now, I want everybody to understand this right here is area. This right here is a percent. And this right here is a probability. Remember me telling you that these are all the same thing. It just depends on what the context of the question is asking. You're going to area, percent, and probability. Now you're going to see that as we get into 7.2. Hopefully by the end of this class, you will see what I'm talking about. Okay, so that's the first question. The second question says, B, you've got a 0.2000 probability that you're going to be late. What does that mean in minutes? Well, we know that area, I'm going to go to the next page here. We know that area is equal to base times height. We know that this is area because it's 4 digits, 4 decimal places. And the height is 1/30. Now I'm going, how do you get rid of multiplying by 1/30? You divide by 1/30. You want one side? You got to do it on the other. And of course, this over here cancels out, and you learned that back in algebra. That's why you did it, so you could get this to cancel. And then you punch this in the calculator. I don't care how you punch it in. You can punch it in 0.2000 times 30, which is multiplying by the reciprocal, or you could do 0.2000 divided by 1/30. Either way you do it, you're going to get 6 minutes. Therefore, if you meet at 10, I don't remember if it's AM or PM, if you meet at 10 o'clock, there is a 20% chance that somebody's going to show up by 10:06. Okay, now that's B. I think they just asked for 6 minutes. Okay, the second type question is kind of along the same lines as this one. It's a time question. And let's type that in, 0.333. And there's a 20% within 6 minutes. Is this a test question? Yes. And the second one is a test question. This one right here is 7.1156. It is a test question. Remember I told you you're going to have at least 2 of these. 7.1, 15/6. Draw the picture. 0 to 30. Height is equal to 1/30 because the base is 30. 15 in the middle. 5, 10, 20, 25. This one only has one question. It says, what is the probability that somebody will be at least 20 minutes late? Okay, now, in order to do this problem, you have to remember what I told you about at least. At least means, in layman's terms, the lowest number is 20. That's what that means. So I'm going to highlight this right here in yellow. At least 20 means the lowest number is what? 20. So I'm going to take my orange pen and I'm going to put a line right here at 20. And I want somebody to tell me what side am I going to shade if my lowest number is 20?
Less than 20?
Okay. What side, it's either going to be left or right. What side am I going to shade if the lowest number is 20?
Right side.
The right side. Now, it just so happens, and this is a coincidence, it just so happens that they both have the same numbers. And since this base is 10, just like the previous question, the answer is going to be 0.3333 again. Okay, that's not going to happen all the time. So since the area is equal to base times height, that's going to be equal to 10 times 1/30, which is equal to 0.3333. And that is this number right here. So this is, like I say, it's a coincidence, but 0.3333. Now, a lot of you say, well, Hubert, what did you do these tables for? Well, these tables have to do with the curve, not the box. So we can't use the tables with the box. Okay, so there's 2 good test questions. I think we did 1 or 2 in class. So you've got 3 or 4 test time questions in your notes to use for the test. Okay, 7.135. This one was sent by several students. 7.13515. 7.13515. Now, a lot of people say, well, we didn't do this. Well, this is a transition question.
This thing is a pain in the ass.
No, it's not.
It is too.
7.135/15. The first thing you're going to do is draw a picture. Now, I have found some students don't draw a picture. Now, I'm talking out of past 20 years. Okay.
Well, what kept messing me up is they were asking you the same question, but they just wanted you to. They worded it differently,
what
and it was screwing me up.
Is remember, okay, let me show you what they're doing. You remember when I did this on that problem and I told you there's 3 different ways you can say the answer right here?
Yeah.
Right here?
Yeah.
That's what they're asking you. They're asking you for different ways to say the answer. And it says the same what? It says the same thing. So I'll get to that in just a minute. All right. So here we go. I'm going to do the first two on this drawing. It says 266 days. Let me find my other one because I don't want to have to add all those up in my head. Here we go. 266, and that's going to be 282. Hold on. Excuse me. 282, 298, 314, and 250, and 234, and 218. And that's saying mu is equal to 266, and the standard deviation is equal to what, 16? I think it's 16, isn't it? Now remember, when you see a sentence, it says that means draw the curve. That's what that means when you see that. And of course, you don't have to draw the curve because you got it already drawn for the 3 or 4 people in the class that actually printed these out. Okay? So I'm going to just add one thing to this, and that is my red area. And I just do that just in case they ask for something unusual. I don't really need it in this problem, but I do it just out of habit. Okay, now, they also tell you a little bit of information about what they're asking you for. They tell us that on the right side of, I think it's what, 280? I can't remember what the question is. I'm trying to find it. Hold on. There it is, 280. Okay, they say beside 280, they say in the question, to the right of 280, you've got an area of 0.1908. Now, I want somebody to read this question right here before we do anything. I want us to read the context of the question. Suppose the lengths of human what?
Pregnancies.
Okay, so you need to write that at the very top of your, I'm going to write that at the very top of my, I'm going to write it in red. Lengths of human pregnancies. I'm just going to say preg. All right? And I put that at the very top of my graph. Now, why did I do that? Because you are giving context to this question. All right, so where is 280? Well, let's take a green marker and let's put 280 on the map. 280 days, meaning that you have gone into a pregnancy and you have carried a baby for 280 or more days. So 280 is right here. I'll take my ruler and I'm going to draw a line going up. And I'm going to highlight the right side of 280.
Wrong side. Shit.
What?
Talking to myself. I highlighted the wrong side.
Do you answer yourself?
I do.
Okay, good. That's a good thing. That means you are certifiably crazy.
I got papers.
Huh?
I said I got papers.
All right, so there is 0.1908. Okay, now I want y'all to think of several ways to describe that green area. And I want you to put it in context to the question that's been asked. I'll start you off. I'll start you off easy. 19.08% of what?
Pregnancies are happening within the first 280 to 300 and
Over, just say over 280 days.
over 280 days.
That's what, okay, that's one way of saying it. So I'm going to go down here and I'm going to write that down. 19.08% of pregnancies are above 200 and what?
280 days.
280 days. Thank you. All right. So somebody give me something else. Not using percent, please. That means I want somebody beside Miss Kidd. She already interacted. Oh my gosh, I got to tell y'all a story about communication. Today at Tri-County Technical College, today I was in my class this morning, and my teams went off saying, "You have been added." And I went, "What have I been added to? Are y'all following me?" Where's Miss Honey tonight? Miss Honey is not here. She's off in somebody's house being kidnapped. All right. She and I wrote an email. I wrote an email to my boss, my dean, and IT, and I said, "Why am I being added to a committee? Does anybody know how being added to a committee, how that works? You got to be what first? Kind of like being married. You got to be asked first, right?"
Yeah.
Okay. Well, I didn't know what this was about, so I sent an email. I had 3 replies saying, "I don't know what's going on. I don't know what's going on. I don't know what's going on." The dean of arts and sciences was confused, saying, "I am lost. I don't know where this is coming from." Well, to make a long story short, after about 15 emails, the person that started adding people didn't write an email to the people he was adding.
Oh, he just put you on there.
Yeah. In other words, he did not what very well.
Ask.
He did not communicate. Yes, he didn't ask. So for some of y'all people that's weaned on a pickle, if you think that I'm crazy about communication, wait until you get in the real world, because that was a big no-no. You did not form a committee without asking people to be on it. I guess he thought we'd just see it on Twitter or something. Anyway, I just thought y'all would like to see that, or like to hear about that, even though it's not going to faze any of me, most of y'all. Y'all still not going to talk. All right, somebody tell me another way you can write this. How about this? The area blank.
The area.
Not Miss Kidd. No, you've already communicated. I'm gonna have to ask Mr. Mance or Miss Gill because nobody else is going to talk.
Obviously.
Yeah. Miss Gill.
I bet they don't have jobs either.
Mr. Mance, Miss Gill, do you want to help me out? The area blank. Okay. Nobody's going to help me out.
280 days is 19.08%.
Oh my God. Who is that? Who is that?
Josh.
Thank you, Mr. Fry. You are a
voice.
winner. The area above 280 days is 0.1908. And then, of course, the last one, not the area, but the probability of a pregnancy, the probability of a pregnancy being over, or whatever, going over 280 days is what?
0.1908.
And that's what they're asking you to do. Okay? So you got 3 different ways to write this answer. There you go.
Please tell me this ain't a test question, because it is aggravating as snot.
Well, there's nothing really to aggravate you now. You know how to do it.
Yeah, but it's just the way they ask
You
it,
just
not
don't
the way
want
you
to let
ask
go, do you?
it.
You just
The
want to
way
keep
they
on
ask it, because
fussing
I
about
done,
it, don't you?
no, I done this question 3 times and still couldn't understand what in the hell they were asking for.
Now do you understand?
Yes.
Okay. Now let's do the other part. Now it says, let me reach for another curve so I don't have to draw it. And here is my other one. And it says the area between 285, so I'm going to take my orange. I'm going to use orange this time. Orange is 285. Oh, wait a minute. I got to do my numbers again. 266, 282, 298, and 314.
Are you doing?
This is B. There's a B to this question.
Yeah.
234 and 218. Okay, the second part, or B, and I'm going to do this in orange. At 285, I'm going to take my and 305. And this is the highlight. Now remember, this is pregnancies over a certain day or less than a certain day, or in this case, not more than or less than, but what? The B word.
Between.
Below.
Between. And this number is 0.1101. So we're not going to write everything out. I want somebody to tell me out loud what that orange area means. And we'll just say carrying a pregnancy blank.
Between
What?
285 to 300 days is 0.1101.
Or 11.01%. So there's 2 questions right there. All right, somebody give me the probability. Or did you give me the probability? Did you say area or did you say probability?
No, I just said the basically the probability of the pregnancy lasting from 280 to 300, 285 to 305.
Is 0.1101.
Yeah.
Okay. And then you could say there is an 11.01% chance that you will carry a child from 285 to 305. And then, of course, the area between 285 and 305 is 0.1101. And that's how you do that. So you just, you pick the most accurate descriptions of those answers. So let's look at the answers.
I don't think it would have been so hard if it's just, I think 50, 90%, 75% of the not knowing how to do the problem is the way they word it versus the way you word it.
Well, look at here. What is the blue area right here? We said that's more than, right?
Right.
Well, it can't be this one.
Yeah.
So that's a given.
Yeah.
The second one is just asking you another way to write A.
Mm-hmm.
So you go down here, which one says more than? B. And you're going to say 285, or what I say up here?
285.
280 is 0.19, what is it? 0.1908. 6 of one, half dozen the other. You just say it the same way.
I could do the test question if you just asked the straight up 1, 2, 3. You know.
I know it can be fussy.
It's
All right,
a
let me
bear.
ask
It's just
this.
too much. It's just
Which
too
one
much.
says between?
B.
So it's B, and then you just fill in. And then you do the next one, you look for between. All right, I'm going to go to the next problem. All right, next problem is 7.2 5/2. 7.2 5/2. 7.2 5/2. Now we're going to have to use 2 curves on this one because there's 4 questions. And I'm going to write them across here so I can just do 2 pages. Okay, left, the area to the left of, and we're going to do the first 2, 1.65. And over here, we're going to do 0.01.
So.
And then on the second curve, we're going to put the area to the left of 0.94 and negative 0.49. All right, so I got my, here we go. Here is my first drawing. There it is. And there's A and B. And where is 1.65? First of all, I got to put 0, 1, 2, 3, -1, -2, -3. All right, 1.65 is a little bit more than 1.5. Does everybody agree?
Yeah.
So there's 1.5. So I'm going to do this in yellow. And I'm going to put 1.65 right there. And I'm going to draw a line straight up at 1.65. Now, the question says area to the what of? Area to the left of. So that means I'm going to take my big highlighter and I'm going to highlight all the area to the left.
Where I was running into trouble with this is when I go to put it in the calculator. When I do the normal CDF, the points that you're putting in, my calculator is not computing them like yours is. And I'm kind of having a hard understanding of why we put the mean and the standard deviation in there.
You don't have to with your calculator.
Oh, yes, I do, because it's all screwed up. It don't give me nothing nowhere near what you've been getting when I watch the video of you doing the homework.
Okay, so we've got this area right here. So I'm going to use my empirical rule, and I'm going to add up everything so I can get an estimate. Empirical rule, so 0.15, 2.35, 13.5, 34, and I'm going to I'm going to call this half of 13.5 is 6.75. So I'm going to say this is 8. And I'm going to add all those together. And that's just going to be an estimate. You could have 7 right here. 34 and 34 is 68. That's 70. That's 83. 91. I'm going to say 92. 0.9200. And that's my estimate. Now I'm going to use, okay, watch this now. Somebody tell me, first of all, is 1.65, is it positive or negative?
It's positive.
Positive.
Okay, so I want everybody, I'm going to put a green circle around that. And I go to my table, watch this. I go to my table, and I'm just showing you this just for your information. This is positive. Z is positive. Down here, Z is what?
Negative.
Negative. So I'm not going to worry about the negative. I'm going to the positive. They've got it bass backwards. I'm sorry. This is positive. Sorry. And this up here is negative because, see, the negative, I don't know why they did that. Sorry about that. Okay. I'm fixing the screen. Hold on. Just positive, thank you. If you just put a positive in there, I'd appreciate it. Thank you. All right, so I want you to find 1.65. So where is 1.6? 1.6 is right here, Hubert. So I'm going to highlight 1.6 across here, and I'm going to highlight that green or blue. Everybody with me? And where is 0.65? Well, that's 1.6. So we got to go up here and find 0.5, because what's 1.6 plus 5 cents?
1.70.
What's 1.6 plus 5 cents? What's $1.65? Yeah. And I'm going to highlight that orange or red.
We had 2.1.
And tell me what number do I have right there?
0.9505.
And that is your answer, and that's how you use the table. So by the table, I get 0.9505. Now I want everybody to look at what I did there, and I just want you to see how I did it. Does everybody see that? I don't want to do this every time, okay? This is the old way of doing it. Anybody got a question on that one? Okay, now let's go to the calculator. Okay, now I'm going to do the new one first, and then we'll see what's going on with your calculator, okay?
Okay.
So second, bars, normal CDF. Oh, that's already there. I guess I did it this morning. I was doing this morning. All right, negative 99999 to 1.65. If you have a new calculator, you can change 0 and 1 and hit paste, and it should be around 9505. Look there. And by the TI-83, I got 0.9584. TI-84, I got 0.9505.
Yeah.
Now, let me ask y'all a question.
That one I got right.
Good. If you get by the empirical rule 0.9200, and by the table you get 9505, and by the TI-84, I think you can pretty much say that the answer is 0.9505. Okay, so let's do this one. We're going to do this one in pink. So this one's going to be in pink. Now, somebody tell me what's interesting about 0.01.
It's half.
Exactly. It's right there at the halfway point. You watched the video, didn't you?
Ain't nothing slack about me.
Well, at least you watch it. You're the one.
I'm the one.
So I am not going to do the empirical rule here because there's no need to. The empirical rule is sitting right there at 0.5. So I'm going to say 0.5030.
You say something different every time you do it, because on the video you said 0.5050.
Well, it's right over. I'm trying to show you that I'm estimating.
Yeah.
I'm trying to get you to see that you don't have to kill yourself doing the empirical rule, because it's just a guess. All right. So here is the pink area, and we know it's going to be around 0.5 something. So let's go to the handy dandy table. Is 0.01 positive or negative?
It's positive.
Positive.
Okay, so I'm going to stay on the positive. Well, let's see, that's 1 penny. So I don't have any dollars. So I'm going to go up here to $0. And I'm going to highlight that green. Trying to use, there we go.
Why wouldn't you use 0.1?
And what is $0 plus 1 cent? I got to add 1 cent right there. And somebody tell me, what is the intersection of those two columns?
0.504.
0.5040. So by the by the table, I get 0.5040. Now, yes, it says 0.504. Yes, that's the same thing. All right, so let's go to our handy dandy calculator. Now watch this. This is a trick I learned in the war. Second, enter. And I'm going to change that 1.65 to 0. What?
1.
0.01. Please make sure you type 0.01 and not 0.1. And let's watch what happens. 0.5040.
Okay, here's where I'm running into issues, because mine says error domain. And wait, let's try it again.
What?
I'm going to try again. Hang on. -9999.
Comma. 0.01.
0.01.
Close parentheses.
Oh, well, how come you don't do the median and the C like you did on the other one?
I told you, the old calculators, you don't have to do this.
Close parenthesis. 0.504. Is that what you said?
That's it.
Yeah.
Okay. So let's do another one. The next one I got is 0.94. I want y'all, if you haven't done it, I'm going to do it in blue. I want you to do 0.94 and negative 0.49. And I'm going to give you a couple of minutes to do it, because I believe y'all are winners. Even though you don't communicate, and you're going to have a janitorial closet as an office because you don't communicate. I'm not talking to the 4 people that communicate with me. I'm talking to the people that don't communicate. And we'll color the other one. Let's see, what did we use? We used pink. I'll do orange. And I'm going to be drawing while y'all are drawing also. And I know some of y'all are using the curve, and that's good because when we get to the 7.2 questions, that's going to help you. But there are people in each class that are not using the picture. And they wonder why they can't do the problems. That's why, because you're not drawing the picture. But it's like I tell my kids, I'm stupid and y'all are smart. Kind of like bar rescue. Those bar owners that are losing millions of dollars, they know how to do the bar business. That's why they're losing millions of dollars. Arrogance is arrogance, and there's nothing, you can't fix stupid and you can't fix arrogance because one leads to the other. I don't need to draw a picture. I know how to do this. Yeah. Why don't you just go on and build the space shuttle, bud?
All right, I got it.
Well, hold on. I got to do mine, and then we got to do the other one. So let me get both of them drawn. And I guess that's orange.
I got a new baby this morning.
What are you talking about?
New baby calf.
Oh, good for you.
Yeah.
We already had mine.
This one was a late one, and she's little.
Loki, can I come pet it?
Good. All right. So let me go ahead and do the empirical rule for the other side.
Okay,
0.15, 2.35, 13.5, and half of 17. Well, I'm going to say 18.
I think I messed up.
Okay. So by my empirical rule, 32 and 34 is 66, 79, 80, 81. I'm going to say around 82 for the blue. And then over here, the orange, the empirical rule, 18 and 13 is what? 31, 32, 33. I'm going to say around 34%. So now I'm going to take my handy dandy calculator. And let me go ahead and show you with the first one is 0.94 positive or negative.
Point
Is
nine four is positive.
0.94 positive or negative? It's positive.
Positive.
So how do you get 94 cents? You got to add 90 cents plus what?
4.
Plus 4 cents. Hold on. And 4 cents. I'm trying. Just hold on. And where do the two overlap? 0.8264. So that's the blue by the table. 0.8264. And while we got the table out, let's go down to the negative. And what are we going to look for with the negative z-score? Negative what? 49. How do you get 49 cents?
Move the decimal 2 places to the right.
No. On here, how do you get 49 cents?
Take 40 and add 9.
Add 40, and that's green or highlight. And where is 9? 9 is right here. And where do the two overlap?
I can't read it.
Okay, they've got the wrong table. Okay, that's not right. Oh, yeah, it is. I'm sorry. I'm thinking of the blue. I'm sorry. I was thinking of 0.82. Where did that 0.31 come from? All right, so by the table, 0.3121. Now look right quick. What did I have for the empirical rule? I had 34 and it came out to be 31, so that's pretty close. Here I had 0.82. Look at there, it came out 0.8283, so that's good. So let's check the handy dandy calculator now. And I take my handy dandy calculator and I do second, enter. And I'm going to do what? 94.94.
Yeah.
Enter. 0.8264. It's a miracle. And let's check the orange. Second, enter. Now watch what I do here because I don't want you to mess it up. Where that 0 is, I'm going to put a negative. The negative beside the enter. And then type in point what? 49. Please don't mess that up because some people will mess it up. There you go, 0.3121. And now you got 3 ways to get the answer. Of course, one of them's an estimate. The empirical rule is an estimate. But you got 2 ways to actually get the answer and look to check it. Okay, now let me show you the rest of 7.2.
I was going to say, there's a lot of these in the first few questions of 7.2.
And guess what?
There's a lot
Those
on
are
test.
4 good test questions. Make sure you know how to do them because those are 4 good test questions we just did. I don't like to give those as 1. I like to give them as 2. I meant 4. So let me go to the homework and I'm going to pull a question. Okay. We just did this one. So let me go to your homework. I had your homework pulled up. Now it's gone. Well, homework 7.2. Okay, we just did one like this one. Next. We just did one like this one. Did one like this one. All right, write this one down. This is a test question. Write it down. And draw me a picture. Draw me a picture. Sounds like a song. Find the area under the normal curve to the left of -2. Okay. So I'm going to take my handy dandy black marker and I'm going to do my z-scores. 0, 1, 2, 3, -1, -2, -3. And I want to know, it says the left of -2. That'll be this side. And to the right of what?
For +2.
+2. Oh, man, this is a good test question because you can do this by the empirical rule. It's not going to be perfect. Somebody tell me what 2.5 and 2.5 is. What's $2.50 and $2.50?
$5.
Oh, $5.
So we know that the percentage here is 5%. So I'm going by the empirical rule. I can say that the two, or you can add all, take your calculator and add all 4 of those up. You're going to get, by the empirical rule, you're going to get 5%, or 0.0500. Okay, now I want everybody to take your calculator.
Hang on. So you add the two together.
Yeah, that's what it says. I think it says that in the question. Just check it and see.
This the area under z equals -2
area.
plus the area under the curve to the right.
Yep.
Okay, let me get my. I'm slow tonight. Sorry, y'all.
Those of you that can go ahead, do the -9999 to -2, and then 2 to 9999. I'm going to show you another way you can do it after that. Of course, you can do the table. I'm not going to pull that table up. Y'all can look at it on your own. I'm going to go ahead and make this big. There we go. I'll pull the table up.
I don't like the table. I can't read it anyway.
Well,
5%.
I'm just showing it for your benefit. So the first one's +2.
Can't read the damn thing.
How do you get $2? You get a +2. And what do you add to $2 to get $2?
No, nothing.
Nothing. So I go to put 0 right here. And I go down. And where does it overlap? Well, it overlaps at 0.9772. Now that's +2. I'm going to, then you got to use the complement, and that's going to blow a fuse, and I'm not going to do that. So I want everybody to take your handy dandy calculator, and I want you to do normal CDF or second enter, and somebody do -9999 to -2, -2.0. Now the reason I did 2.0, well, I'll just do 2. I don't want to in comma. I have to do that on here because the new one, I gotta fix this. There we go. And
Okay, so you said take Negative
I'm sorry, I
9999.
hold on a minute. I just cleared my dadgum computer. Hold on. I you get irritated when I do that. Second, enter, and I'm going to change this to negative 2.0. Okay, now what was your question?
So basically, when I put it in the bars, it's the negative 9999, comma, negative 2.
And then close
And then
parentheses.
that's, yeah, parentheses, and then that's 0.2. And then the other side, basically the same thing, ends up being
Thank
0.2.
you. You stole my thunder, but that's good. That's the third way that you can do it. Look at the drawing.
I'm sorry. I'm just trying to
That
figure
is
it
correct. Since the two are what?
out.
Symmetrical.
Symmetrical.
You just take that, take this right here, which was what? What was the
So
0.0228?
5.
0.0228 and multiply that by 2. And I'm going to do that right now. Multiply that by 2. And your answer is 0.0455.
Hold on. What? Okay. You just lost me.
You answered the question.
No,
You're the one that answered it.
I know. No, I did the.
You said, this is what you said. You said, since they're both the same, why can't I just add those two together?
Yeah, but you're multiplying. You're not adding.
Multiplying.
0.2 and 0.2 is 5.
Okay. When you multiply by 2, that's the same thing as adding another number. It's the same thing.
Shit, I don't know that. Hell.
0.0228 plus 0.0228 or 0.20228 times 2, you'll get the same number.
So you still end up with 5% is what you're saying.
Well, the z-score is more detailed. Remember, the empirical rule is an estimate.
So the
And by the
z-score,
empirical rule, we got 5%. It really came out to be 4.55%. Or 0.04.
oh, this is so aggravating.
So let's type it in. 0.0455.
Oh.
And that's it. Find the area left of 1.54. Now this one, first of all, is this symmetrical? No.
No.
So we got to draw another picture.
Freaking test question. So A is equal to 0.0455.
And I'm going to draw a picture while y'all are drawing a picture. 0, 1, 2, 3, -1, -2, -3. Now, since these are not symmetrical, I'm going to use two different colors. The first one says -1.54. There's 1.5. So 1.54. I'm going to show this to you in just a minute. That's -1.54. And then I'm going to do blue 2.54. Okay, now look at my picture. The first thing you should be doing is you should be doing your empirical rule and getting an estimate. That's why these pictures are so important. Okay, my empirical rule on the left is 0.15, 2.35, and half of 13 is 6.75, but we ain't gone half. We less than a half. So that will be maybe 5 or 6, whoever, you can call it either one. I get 5, 6, 7, 8. I get 8% or 0.0800. Now that's my estimate for the orange. And for the blue, my estimate is going to be 0.15. Somebody tell me what's half of $2.35? $1.17, Hubert. So that'd be less than 117. So I'm just going to say 1.00, and I get 1.15, which is 0.0115. So my estimate for this problem is, what's 8 cents plus 1 cent? 9 cents. So 0.0915, and I'm going to write that in black because that's my estimate. 0.0915. I want everybody to take your calculators right now. And I want you to add up.
Hold on. Did you add those two together?
Right here.
Okay.
And then add up your empirical rule estimate right here. Remember, it's an estimate, so it doesn't have to look like mine. It's an estimate.
Did you get the 5 from half of 13.5?
Yeah.
Okay.
And you could say 6. I just went a little bit less. It's probably closer to 6, but I just did 5. Remember, you're just trying to get in the ballpark. You're not trying to answer the question. And then I want everybody that when they get through doing the empirical rule, I want you to go from negative 9999 to negative 1.54, and then 2.54 to 9999, and add those two together. So y'all work on that. I'll put the negative 9999 right here. And then the positive 9999 over here. Do y'all see why the pictures are so important? If you were trying to do this in your head, you wouldn't make it. You wouldn't make it.
All right. So negative 1.5.
That's why people can't do. That's why people drop out of 120, because their teachers don't even tell them to draw a picture.
They just say, figure this shit out on your own.
That's pretty much what they do.
I bet their damn passing rate ain't worth a shit either, is it?
No, it's not.
Well, let me ask you this.
Well,
Isn't your...
we got some good ones. I'm talking probably out of 10 teachers, there's about 2 or 3 that are just getting paycheck.
I was gonna say, how do they continue to have a job if students can't pass their class?
Can't find math teachers.
Okay, so and you told me are we supposed to be adding these together?
Yeah.
Okay, so
remember the question says that. Remember to read the question. I know I don't have it in front of me.
I can't even pull the question up in front of me on my computer because
what does it say right here? Plus the what?
Plus, okay.
Plus the area. So it'll tell you. What is that noise?
It's my phone.
Okay.
I'm doing some business. I'm sorry.
Business.
Making money, yeah.
Must be the dang old Dogecoin. Dang old stock.
No, buying and selling saddles.
Oh, okay. I'd rather deal with stock. You know why I'd rather deal with
damn
stock?
part of that shit.
I don't deal with people. That's why, because they bitch too much.
I don't know. I just don't. I don't know. Look, I flunked economics twice in high school, and I don't want no damn. They ask me all the time about what I should invest in my retirement, my Prudential retirement account. I don't have a damn clue.
What you ought to do is just get a 401k, and that way you don't have to worry about it.
I do have a 401k.
You just put it off and forget about it.
That's what I do. I
Just
get so much
money in
put into there. Yeah, I get 10 or 15% of my income put into it.
Keep putting in it.
They
That's
just
called,
invested
you know what
in-
that's called? That's called a good decision. Wow. What happens when you make good decisions? You know, during high school, during college, what happens when you make good decisions? I'm just going to leave it at that. You're criticized. That's what happens. All right. So here we go. I'm going to take my handy dandy highlighter. I'm at my calculator, second bars, normal CDF. I'm just redoing it. Negative 9999 to what? Negative 1.54. And if you got an older calculator, you'd close the parentheses after negative 1.54. And I get 0.0618. 0.0618. Now let's do the blue. Second entry. And now I'm going to go from positive 2.54 I'm sorry, I'm just about shot. When I get to 8 o'clock at night, I'm just about shot. 2.54, comma. Now watch what I do here. If you've got a new calculator, I'm going to just put all nines because I don't want to have to mess up this stuff. So I'm just going to hit 9999 until I get to that comma. Okay, and hit enter. That's if you got a new computer, new calculator.
So
0.0055.
I hope I got this right. But see, for some reason, I got a negative when I did it.
Check it again.
And I did. All right. So
Can't have a
second
negative
bars.
probability.
Negative 9999, comma.
2, comma, negative 1.54, close parentheses.
Where the hell did negative 154 come from?
Are you doing the orange or the blue?
Oh, there it is. Negative 1.54. Yeah. Close parenthesis. 0.018. No, I'm talking about I got a negative on the other side. And how, I don't know.
We'll just fix it and you don't.
9999
9999.
plus 2.54 close parenthesis. This damn thing is 9999, comma 2.54 close parenthesis. Correct?
Now you read from left to right. You should be saying 2.54, comma 9999, close parentheses.
Okay, so I got the same answer. It just wasn't a negative. So I did it right, just the sign was wrong. And I ended up getting, when I added those two together, 0.068.
And I got 0.0618. Now let's look. I got 9% as an estimate, and the answer is, you add those two together, is 0.067, what, 12 with 2, 7 what, 3. 0.0673. Can somebody verify that?
.0673, correct.
And that's your answer.
Okay.
Now, this is just like playing the piano. You got to practice on your calculator. You practice by drawing a picture and doing it on your calculator. And the only way to get better at it is to do it what?
Again.
Over and over. No, the best way to do it is to sit and let it sink in by osmosis. That's the best way to do it. No, the best way to do it is like Mr. Mance said, do it over and over and over. Okay, now I'm going to check the roll right quick. and turn off the handy dandy recording.